Hello, YouTube.
Hello, folks.
We
We
seem to have
Clemence's screen
and
and
a
a
functioning
functioning
Zoom
Zoom
recording,
recording,
and
and
we're
we're
only
only
a
a
third
third
of
of
the
the
way
way
through the lecture.
lecture.
Let's see what else we can make go wrong. Okay.
Okay. Indeed.
So
Uh,
we're gonna. So this was our. You can see
you
on
can
the
see on the
screen
screen
a different version of how to.
Uh,
Can you see? Can you spot the difference from what we did on Friday? On Friday, in our step case, we said that how to of successor of x was 2 times how to of x. And now we've got a different way of doubling. Just adding the thing to itself. Slightly, I mean, from all you know about how adding and multiplication works, we have done apparently nothing. However, one of the things you find is that when you're getting off the ground like we are with this construction of arithmetic as we know it, the way you cook the definitions has a profound influence on the way the proofs go. When we tried it this way in our rehearsal last Thursday, we got into quite a lot of trouble. And then we thought, well, you folk experience being in that kind of trouble all the time. So at the least we can do is show what happens when we get into trouble as some way of helping you fight your way out of the various wet paper bags in which I place you. So shall I see if I can use
so shall I see if I
okay. I mean, we're going to take it in turns.
In this case,
sure, yeah, it's your computer, so I'll go first, because that would be funny when I go wrong. Right. Yeah. Okay. So we're going to play the usual game of why is it stuck? And let's have a look. Why is the left-hand side stuck? Well, how to only has one input, and it needs to know what that is. And its input is A plus B, and that's stuck because A is stuck. So that's to say the left-hand side is voting for A as the thing we need to poke. The right-hand side, on the other hand, is stuck. Multiplication works by recursion on its second input. So it's stuck because power to B is stuck. And power to B is stuck because B is stuck. So the right-hand side is voting for B. This is what we call bad news. We got conflict, right? So we know there's trouble ahead, but we should still face the music and dance. We also know that if we make how to be compute a little bit, what will bubble out is something plus something. So multiplication still won't do any work because it won't see any successor symbol. So I'm gonna because I mean let's do it. Let's do it, right? There's no point in me. I'm telling you what I'm thinking. But if I just do it, then you'll see. We get a step case, annoyingly, where there's a zero on the wrong side of a plus sign. And then here also, we're getting in the step case, We're getting stuff on the wrong side of plus. Oh, I don't know how to use your. And now I've done something really stupid. We're in override mode. I think I fixed it. I just hit the wrong key. So we say test, and not very much happens. We get an annoying plus in a funny place here that doesn't allow any computation to happen. So this looks bad. Going with B gets us not very far. So I'm going to give up on that. I'm going to go with A instead. Because then at least I know I will get something happening on the left-hand side. And here, good news, no base case, only a step case. That means we're computing something properly. And in the and we've got a step case where we've got something that will compute. Okay. So that's okay. I hope you've got the rest of the file further up. Yes, in what sense? All the library stuff. Yeah. Okay. So, what do we see? On the left-hand side, we see two copies of power to x plus b. Well, first of all, someone we were asked, what does inductively mean? When I say inductively, in a definition or a proof, I mean, I promise that the thing in this case, A's position, is going to get smaller as we go along. So the basis of the explanation is that things can't get smaller forever. So what that means in practice is that I am entitled to some knowledge. Is it Control C to copy? I think so. Maybe I will.
For Emacs, it has its own.
Yeah. Yes. Let's see what happens.
Control Y for pasting in the case.
Yeah. That did nothing. That was bad. Do you know how to copy and paste?
No, I know. That's my problem. Wait a second.
I wanted to copy that thing.
I have a very bad. No. Wait. Copy is okay. I know what it is. It's Alt W.
Right.
Sorry.
Okay, cool. Right. So what we're saying is that we know So what I've done here is I've explicitly written down in a comment the induction hypothesis that we are entitled to. So inductively means I promise A will get smaller, and then from A means where did A come from? How was it made? Look at the data type for the thing that A is, namely a number, and ask which of the ways of making that kind of data was it? Was it zero or was it a successor? We're in the case where it's a successor. We've exposed that X is the thing one smaller than A, and that means we're entitled to assume that our result already is true for X. And from there, we're trying to show that it is true for A, namely the successor of X.
In the Zoom.
We can look at the chat if you want to send us a message.
Max, can you just chat? I mean, put it in chat if you have a question.
Yeah. So yeah, so this is the thing we're trying to make use of. Now, what can you see?
What's the should mute this Zoom?
Yes. Let's mute this one. Are we anyway?
One second up here. Yes.
To add comedy to. What am I doing?
Oh no, you activated the whatever.
Right. So this is
what the heck?
You've got tap click, haven't you?
Maybe, but
yeah. So now I'm just graffitiing all over things by accident.
Let's just ignore the graffiti.
Yeah. Okay. So you can see the induction hypothesis in the comment. Does it do you any good? What you need to do at this point is look in the goal for some bits and pieces that are to be found in the induction hypothesis. Can you see either the left-hand side or the right-hand side of the induction hypothesis lurking somewhere in the goal? Can you see any pow to x plus b knocking about? Yep. You are way ahead of the game, but exactly this is what is going to have to happen, right? You can see that our internet connection is unstable. I mean, and you can see that, you know, I made orange messes. You can see that in order to get closer to the right-hand side of the induction hypothesis, we are going to need to multiply out the brackets on the right-hand side. In the meantime,
yeah, I mean, rearranging doesn't work correctly.
Yeah. So you're thinking, you know, in high school, I know I'm just allowed to multiply that stuff out. And the point is, to some extent, we're not there yet. Now, I can see the left-hand side of the induction hypothesis occurs in two places. So I can at least make some progress. Let's do it. I see that the left-hand side of the goal contains not one, but two copies of the left-hand side of the induction hypothesis. So I'm going to just replace the left-hand side of the induction hypothesis wherever it occurs by the right-hand side. So I'm choosing this thing as a stepping stone to put between the left-hand side of the goal and the right-hand side of the goal, because I know I can reach it using the induction hypothesis. And I've got too many parentheses. Okay. And then I know I can get from the left to the middle with under plus. Just to expose the two occurrences of the induction hypothesis. So that much is good. And now you can see that the remaining goal is given exactly by multiplying out the brackets. And remember, the other day, we proved that you can multiply out the brackets from the left. We need to multiply out the brackets, multiplying on the right. Bugger. Clemens, get me out of this.
Let's see where we get to this. So let's do that before all that, because we need this in the proof. So what do we need? We need, 1 second, that A times B plus B times C.
You need to be...
sorry.
Yeah.
B times C, I guess.
Be careful.
Do I need spaces here?
No, it's not spaces that you need. It's you need to get things the right way round. Right. You need the same multiple on the right.
Ah, yes. So we need A, and then we have...
No, you're lining up to... Yeah.
Nobody knows where the right is. So
Yes.
I mean...
Nobody knows where anything else is these days.
Yes, okay. And this is now the same as A plus B times C.
Right, so does that look like distributing, multiplying on the right? Looks good to me.
I think that looks all right.
Yeah.
Now what do we do? Where are we stuck here?
Well, yeah. Well, you should see. So we're thinking this is the law we need. We should see if it's fit for purpose. Try commenting out the goal that we have that we're stuck on. Yeah, stick two minus signs in front of this Haskell comment.
Ah, okay.
Yeah.
1 second. Yes.
And then hit tab.
Ah.
Right. So you see what happened. Ask is now happy that the new thing we're going to prove is strong enough to solve that goal. If we had commented it out without stating this law, Ask would have asked us for it again.
I can briefly show this by commenting it out, and then
you see, goal reappears.
Indeed.
So Ask is happy for us to disappear the goal because it now believes it. Pro-town. It's still not giving us green and proven because we're relying on something we haven't proven yet. But cool, we've got it. We're giving ourselves the algebra that our friend in the audience was asking for. Let's see if we can get there. Do you want to do this one?
Okay, let's have a look where we get to this. I don't remember, however, what is the right choice here. So
well, play why is it stuck?
Well, why is it stuck? It's stuck because of the A times C, but then the A times C in the first instance would be stuck on the C.
Right.
Ah, and the right-hand side is also stuck on the C.
Yeah, 2 votes for C, no votes for anything else.
Very good.
Fantastic. Do it.
Good. Inductively C, and then we do from C.
Yeah.
And then what? Okay.
And then I will do the magical incantation.
Yes. Something that I'm trading, but it will still go horribly wrong today.
So, and then we say test. So someone was asking, what does test mean? Test means use the definitions to do as much computation as possible and see where that takes you. So when we write definitions, we are writing the equations that say how computation makes progress. And when we say test, we mean just do it. Just run this program.
Which I just did.
We lined up a situation where we could just run this program.
Indeed.
Okay.
And now if we ignore the graffiti.
Yeah. What's our situation? Well, so you should say, if you can do the copy and paste thing again, what the induction hypothesis is. We copy the goal and we replace, in this case, C by X.
Oh, okay, fine. I'll do that.
And then we go hunting.
Indeed.
Can you see either side of the induction hypothesis lurking somewhere in the goal? Can you see the left-hand side of the induction hypothesis lurking in the goal? You can see some bits of it. You can see a separate A times X and a B times X, but they're not next to each other. We're certainly going to want those pieces, but we're going to have some work to do. What about the right-hand side of the induction hypothesis? Can you see it in the goal? Yes, you can. There's an a plus b times x sitting right there. So that means the induction hypothesis will allow us to take a step from the right-hand side towards where we need to get to. It's not going to get us all the way there, but it will be progress. It will introduce an a times x and a b times x, although not quite where we want them. We certainly want those pieces, and we hope to rearrange them later. So why don't you cook up a route to go from the right-hand side?
So by root.
So yeah, so you pick up the whole right-hand side of the goal.
The whole right-hand side.
Because we're going to step from the right-hand side. And then you...
please. Yeah. Okay, good. Sorry.
Yeah.
This was bad.
Yeah, and then you replace...
Wait, no, that's the wrong thing. I just did the wrong thing. Just give me 1 more second.
Yeah.
Good. Yes.
So that's the right-hand side of the goal, and now you replace the thing that you know something about. You don't want an equal. You want to replace a plus b times x by the left-hand side of the induction hypothesis.
Indeed. So we put here a times x and b times x like this.
Yeah, 1 more paren, I think.
Yes.
And then hit tab. Okay, so now we get...
What do we get?
We get two demands. Left to middle and middle to right. And middle to right, we know we can knock off with under plus.
Middle to right, which one? This one here.
The bottom goal is the easy one.
Yes, under plus.
Yes, because we rewrote by the induction hypothesis under a plus, so we know we can justify doing that with under plus. Okay, but now we've got entertaining trouble.
Entertaining indeed.
Yes.
Basically, we have a plus b plus c plus d, but we want to switch around.
Yeah. So
you had a name for this.
As the notorious 1970s comedian Eric Morecambe once said, I'm just putting the extra brackets in so you can see exactly what's going on. I'm playing all the right notes, but not necessarily in the right order. You can see that we are adding up the same 4 lumps of stuff. They're just not very helpfully grouped. You see what's going on? We know this equation is true. In high school, we wouldn't even think about having any difficulty with it, because we know we can add stuff up in any old order with any old bracketing, but we haven't learned that yet, so it's time to start now. What we're basically saying, so it's my go, is that whenever you have 4 things to add up in 2 groups of 2, you can change partners. Isn't this the law we wish we knew? Yep. So let's see if I can just comment out the goal that needs that law. And yes, I can. Okay. So how do we prove this? You can see that the A and the D are a bit of a distraction. They don't move. But we're going to have to get the B and the C past each other. So this game goes in 2 phases. Getting rid of the A and the D, and then proving that we can swap the B and the C. Okay. So this is a situation, this is exactly the situation where under is not your friend. Right. At the moment, we believe this goal, right? at least informally, if we start by saying under plus, we get two separate sub-goals. Do you believe either of those goals? Remember, when you see a variable, that means the devil gets to choose them to mess you up, and she's very talented at that. I think the devil can probably choose A, B, and C so that A plus B and A plus C are different. So yeah, that was not a good move. Let's not do that. But what we do know is that plus is associative. We proved that ages ago. And I can use that fact to line up the pluses so that an under plus will do us some good. Right, so I'm gunning for the A's. I want to get rid of the A's. And that means I need to get on both sides of the equation the leftmost plus to the top. So I'll say by root A plus B plus C plus D. So all I'm doing is using associativity of addition on the left-hand side of the equation. So I only get one sub-goal because ask is happy that plus is associative. And now I'm going to play the same game on the right. Okay, and now I've lined up pluses with A on the left and other stuff on the right. So if I do under plus here, the A's will disappear. Because I'll get two sub-goals. One of them is just to prove that A equals A, and that's obvious. And the other one is something reassuringly simpler than what we started with. Okay? So now we've got as far as we got rid of the A's. Now we've got to play the game in exactly the opposite direction to get rid of the D's. So now I've got the D's lined up. Oh, I've done that again. At least I know how to undo it. Right. So now I've just got down to proving that that plus is commutative. But I can tell that I'm not going to get any further in this proof because this isn't gonna, both sides of the equation are stuck. And I'm going to need a fresh inductive explanation to get those computations unstuck. So again, I'm going to bail out and leave that one for Clemens.
And I have no recollection whatsoever about this one.
Well, yeah, but this one you don't need to remember because because there are only two things you can do and they're both the same.
Okay, let's reassuring. C plus B.
Yeah. Yeah, so comment out the one in the previous proof.
This one here.
Yeah.
And now we do inductively, I guess.
Well, yeah, have you hit tab just to make sure we're in the room? Okay. So, folks, if you play Why Is It Stuck, then you get some bad news. Because the left-hand side is voting for B, and the right-hand side is voting for C. So you know you're in trouble. However, you can also see that because the goal is symmetrical, it doesn't actually matter which you pick, right? it's going to be bad, but at least whichever one you pick is not going to be wrong. So that's something.
Yeah, I like this. Okay. Let's pick B just for the
yes, why not?
And do a from B. Now we are really getting to the wire.
We're going to leave a cliffhanger, I can tell. Yes.
Is this the moment we do a test?
Yeah.
Okay, test.
We'll get some computation.
Okay, good.
Right. And we should write down what we think the induction hypothesis is.
Let's see. The induction hypothesis is X plus C equals C plus X.
Yeah. Okay, folks. So you see why that's the induction hypothesis? Because X is smaller than B. And we play the usual game. We're looking to see if we can spot either side of the induction hypothesis somewhere in the goal. And then we're going to switch out for the other side. Can you spot it? You can see on the right-hand side of the goal, there's an inconvenient successor getting in the way. But on the left-hand side of the goal, we've got the left-hand side of the induction hypothesis in one piece. So that tells us what route to pick. We copy the left-hand side of the induction hypothesis, of the goal rather, but we rewrite by the induction hypothesis. So that's successor of C plus X.
I'm hoping this works.
Go for it. Okay.
Wait, what happened now?
What happened there?
Sorry.
Oh, you need to get rid of the question mark.
Okay, sorry.
All right. So we're as far as we can get here because of that annoying successor in the wrong place. So once again, you can see both sides of the equation are stuck, but they're stuck because we need to think about C. And we knew that would happen. We knew that would happen right at the start when the right-hand side of our goal we noticed was stuck because of C. We knew this moment would come, that we would need to worry about C. So I want to do, let's see if I'm lucky. I'm lucky. So once again, we pull out the goal as a new problem, and then I hit page up by accident. And we comment out the old thing. And ask is happy that our new goal solves our old one. And now we're going inductively C from C and then test. And all of a sudden, everything has worked out just in time. Anyone would have thought we spent 20 minutes fanning around at the start of the lecture just for dramatic tension. But still, somehow, we did all the padding at the front. Isn't that fantastic? So, anyway, I hope your week goes better than ours is at the moment. And we should really quit while the going is good.